Over the past year, our community has witnessed remarkable achievements across artificial intelligence research, teaching and thought leadership, from experiential learning research projects to innovative teaching methodologies and that empower the next generation of artificial intelligence leaders. These collective efforts aim as well in shaping the future of education and empowering individuals to become leaders in this rapidly evolving field. As we reflect upon the years that have passed of groundbreaking advancements and enthusiastic reception of artificial intelligence, it is with immense pride and gratitude that we present to you, ladies and gentlemen, Speak to a Scientist program event, a platform whose objective is to provide an opportunity to clarify thoughts, generate conclusions, develop theories through asking questions differently, and to expose our clientele to latest ideas and perspectives, thereby encouraging the growth of new understanding. Ladies and gentlemen, good morning. I'm Kolani Nameka. I'll be your host for this Speak to a Scientist program. Today, I'm joined by our own distinguished guest, Mr. Daniel Matsapula, who is the African space scientist with over 20 years experience in the global space industry, spanning 3 key government space organizations in South Africa, namely the Department of Communications Institute for Satellite and Software Applications from April 2001 to June 2008, Council for Scientific and Industrial Research in CSIR Satellite Application Center from July 2008 to March 2011, and the South African National Space Agency, which he is currently in Earth Observation Division since April 2011 as founding member of SANSA, which is the South African National Space Agency. Den's exposure to the international space industry took off when he joined the CSIR Committee on Earth Observation Satellites Secretariat, where he championed South Africa's data democracy for developing countries' legacy project in Africa through advocacy on such platforms as the European Union's Framework Program, 7 Projects GEO Network for Capacity Building, and the African Monitoring of the Environment for Sustainable Development in the SADC region, where open data sets and software tools were shared with all the 14 participants SADC countries' ministries of environment, agriculture, and universities to develop capacity in the use of Earth observation in the region during 2009 to 2013. He currently coordinates Earth observation capacity building nationally through platforms such as the National Disaster Management Center, National Capacity Building Coordinating Committee, and global through his chair role since November 2023 of the CEO's Working Group on Capacity Building and Data Democracy, to increase the capacity of organizations in developing countries to effectively use Earth observation for sustainable development with other space agencies. Ladies and gentlemen, please join me as we welcome Mr. Dan Matsapola, a space education manager at SANSA. Ladies and gentlemen, let me give all the reins to Mr. Daniel Matsapola, who is, like I said, the space education manager, to share with us what is it that has been happening lately on space. Over to you, Mr. Daniel Matsapola, and then after that, we'll take the Q&A from him. If there are questions, please put them on the chat box so that I can read them out to Mr. Matsapola. Thank you very much for joining us, Mr. Matsapola, and all the reins to you.
I want to share with the audience, a few slides regarding our place in the universe, just to help us have a perspective of where we are as planet Earth in the greater scheme of things, particularly in the galaxy. And of course, there are billions of other galaxies outside of our own.
Yes.
We'll touch on the space value chain, which is the real crux of this presentation. We'll look at nature and how it inspires science innovations. I will talk about outer space environment, that dangerous platform in outer space, where you can die if you are ill-prepared in your mission in outer space.
Wow.
Then my unit, the Space Education Unit, and our link to the Sustainable Development Goal number 4, which is quality education. Then we'll talk about man-made satellites and their everyday uses. And I'm hoping on the platform there are young people who are in schools, but then even members or elderly members of society would derive value from the presentation. We'll talk about careers, and then I've done some analogies between outer space and life on Earth. So this is a slide that was shared with me by my friends at NASA, the astronaut who visited us. This is the Milky Way galaxy, and we are that little dot there on the western part of the galaxy. And it really humbles you, especially when you think the planet we live on is so big, and like a radius along the equator of 40,000 kilometers plus. So when we bring it back down to an area we know pretty well from primary school, natural science, planets are natural satellites. And I'll define what a satellite is in the next slide. And so you ask ourselves, what is a satellite? Because in outer space, we build satellites on Earth and we launch them using rockets into outer space to have them orbit around the Earth and perform specific functions that will support our value creation and value extraction processes on Earth. Things that make our life easier, things that enhance life on Earth. So when you move away from my very energetic mother just served us noodles, which is Mars, Venus, Earth, Mars, and all the other planets in the solar system, noting that Pluto is no longer classified as a planet, it's a dwarf planet. We bring it home to the two natural satellites that we see in our immediate environment. One is the one we live on, planet Earth. It's a satellite in an elliptical orbit around the sun. And the red line, that is the orbit planet Earth. It's an elliptical orbit, not a circular orbit. So the shape of it means that there would be times when planet Earth is closer to the sun, and there will be times when planet Earth is much further from the sun in the shape of an ellipse. So Earth is a satellite. So congratulations to the young people on this platform. You live on a satellite. But until the 3rd of October 1957, planet Earth only had one satellite, a natural satellite called the Moon. And so the Moon is in orbit around planet Earth, and it takes exactly 1 month to complete one orbit around planet Earth. So these are natural satellite examples. So a satellite is any object, normally smaller object, that orbits around a larger object. That is what a satellite is. So when we studied these natural satellites, and we began to understand the laws that govern the movements of these satellites around each other, celestial bodies around each other, the Earth around the moon, sun, the Moon around the Earth. We realized that those laws studied by the likes of, say Isaac Newton, of course, but Johannes Kepler is among the people who studied this in greater detail, Galileo Galilei. So we realize that power lies in us using the laws that govern these movements that are operating with mathematical precision. We can use the same laws to build man-made satellites and launch them into outer space. And on the 4th of October 1957, for the first time, humans experienced the phenomenon of a man-made satellite launched into outer space by Russia, USSR. At the time, Ukraine and Russia was one country. Today, they are in conflict. So Russia is the first one to launch a satellite into outer space. And 81 kilogram Sputnik is the name of the satellite. Not much intelligence built into that satellite back in that time. At the time, it was a proof of concept. We wanted to know, is it possible? And what will the satellite do for us when it's in outer space? And all that Sputnik did was make a beeping sound that goes something like beep, 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 beep. So those who were tracking it on different parts of the planet, including South Africa, yes, in South Africa, the CSIR had a capability to track that satellite, Sputnik, in October 1957. As part of the NASA operation, South Africa used to play support role to the early NASA missions as well. You know, the missions, Apollo may be very familiar, that landed man on the moon in 1969. We played a big support role, and some of our innovators from South Africa actually contributed significantly to those missions. Of course, it was largely only white people that participated. What gives me excitement today is that the South African National Space Agency, an entity of the Department of Science, Technology and Innovation, is opening up opportunities for young black children, boys and girls in rural areas, far-flung areas of South Africa, townships of South Africa that are not even in proximal existence with any of the space facilities, to be able to play a role to study space science and technology at the various universities offering engineering degrees. You know, Stellenbosch University is where I studied. And of course, it happens to be the university that built South Africa's first satellite and had it launched by NASA in 1999 to go into outer space. It was an Earth observation satellite. It had a powerful camera that can resolve the hair on a lion's face from 500 kilometers altitude. And you know, the mane of a lion on a lion's face has got different colors. There's dark, there's brown, and light brown. So that camera from a raised platform on Earth was able to resolve the mane on the lion's face. And that's what qualified that camera to say it's good enough to do the same at 500 kilometers altitude in outer space. And that is how we test these instruments before we put them inside satellite systems and launch them into outer space using rockets to go and perform specific functions like resolve any two objects, you know, 8 meters apart. And increasingly, as technology improves, nowadays we are able to even see an elephant in the Kruger National Park. And that's because of high resolution, spatial resolution satellites in outer space. All right, so South Africa has 13 satellites in Earth orbit launched into space, from the number 1 being SANSAT, and number 2 being Sumbandila Sat, number 3 being Tsepiso Sat in 2013, number 4 being ZA Cube 2, a mission that I cannot stop talking about. ZA Cube 2 was built at Cape Peninsula University of Technology, the FSATI program there, which is French South Africa Technology Institute, that dealt with the development of satellite systems. They developed cube satellites and launched them into outer space. Now, the ZA Cube 2 satellite mission, it's a satellite mission that deals with, among others, monitoring failed fires on Earth. There's a sensor built by the CSIR there that excites me because it will make for students and learners in the school system understand the periodic table in much greater detail. The name of this sensor is called the K-line sensor. This K-line sensor, K being potassium on the periodic table, it means that it was a great innovation compared to previous technologies that were used to collect fire signatures on Earth, like thermal infrared sensors, which sometimes picked up things like mines because they generate a lot of heat from their operations. So the data would then create a false alarm for the remote sensing community, fire protection association, environmental managers who are really interested in these fires, because they must make sure they do not cause damage to the environment. So the K-line sensor was then able to subtract all those false alarms created by the mines, largely in Mpumalanga province, where it looked like with thermal sensor, infrared sensors, Mpumalanga is on fire, when in actual fact is the mines. So with the K-line sensor, because there is a lot of potassium in plants, and when plant biomass, particularly brown leaves, burn, they emit a potassium signature. And the sensor on board the satellite in outer space picks up this signature and alerts the fire protection agencies, the CSIR, of course, and other operators. We used to have the advanced fire information system developed by the CSIR. So these satellites are really helping us solve real world problems, not imaginary problems. So when you talk of outer space, access to space is very critical. And that is why Department of Science, Technology and Innovation funds University of KwaZulu-Natal Aerospace Systems Research Institute to develop South Africa's satellite rocket that's going to launch satellites in outer space. So below that 13 in Africa, which is Kenya, and that 7 in Africa, which is Algeria, we need to have in the southern part of the, sub-Saharan Africa, in South Africa, we need to have a rocket launch site at Nel Overbeck Test Range. That's where I started my career. It is the only place in South Africa where a rocket was successfully launched into outer space. So we've successfully built a country which we're going to get young people in schools in a competition to name that country. It was launched by the Department of Science, Technology and Innovation, the Deputy Minister, with players in the space industry, including University of KwaZulu-Natal, the professors who are leading that rocket building capability, to give South Africa a sovereign capability to launch satellites that it builds within its own territory without having to go and ask for a launch vehicle from other parts, which is what we've had to do with the 13 satellites that have gone to outer space. So when we talk of outer space, what exactly are we talking about? You see, it is always defined relative to planet Earth. So planet Earth, being where the 7-8 billion people live, is surrounded by an atmosphere. And we humans, of course, because of our average height of over 1 meter, we live in that troposphere. Our heads are in the troposphere. And of course, aeroplanes don't fly in outer space. They are in the atmosphere. And then, of course, you look at the thermosphere part of the atmosphere layers. That's where the Kármán line, that red dotted line, that's the beginning of outer space. So if you could imagine a car that could drive vertically up, and you drive it from the face of the earth vertically up in any direction, and you at 100 kilometers per hour from the first second, and you maintain that speed, 1 hour later you would cross that imaginary line called the Kármán line. And if you took a U-turn at 101 kilometers, technically you were in outer space. It's called a suborbital. So what you want to know is that there are different layers and levels in outer space. the entry level into outer space, if you can't go there, you can't go anywhere else. It is the easiest place to go. South Africa has been stuck in this area. It's called low Earth orbit. All of South Africa's satellites have been destined for low Earth orbit. And that is why I am excited when the Department of Communication and Digital Technologies, with its implementing agency, Centec, and partners, Department of Science, Technology and Innovation, and SANSA, we are discussing South Africa's telecommunication satellite. The feasibility study has been done. Now we are looking at ways it will make business sense to build this satellite and have it launched into outer space and deliver services, because currently we are spending lots of money, billions of rands a year, to rent transponder capacity from other people's satellite missions. And therefore, we are having this negative flight of capital leaving our shores. Capital that could very well be creating jobs for our unemployed youth and create opportunities for building an entire integrated space capability. Companies that are developing particular subsystems to actually help us build satellites that are destined for outer space. So medium Earth orbit, so low Earth orbit is below 2,000 kilometers, and it starts, of course, where outer space begins. That's where you will have land imaging satellites that are imaging South Africa's 1.2 million square kilometers of land. And of course, some of them are interested in the oceans, and some of these satellites are actually collecting data over our atmosphere. Dr. Lerato Shikwambana at SANSA Earth Observation is leading the team that deals with air quality monitoring, which is going to be used when it's developed fully as a decision support tool by Ministry of Environment, where South African Weather Services is just an agency. So we're looking at really developing solutions in this era of climate change, helping us cope with the negative and adverse effects of climate change. Southern Africa is turning into an oven and temperatures are rising. So therefore, farmers need to find assistance in coping with this, because even the plowing seasons are changing, which affects food security. And so as a nation, if we want to retain food sovereignty and we don't want to be dependent on other nations, we need to invest heavily in such programs as the CSIR is running, called precision agriculture, where we are able to graduate subsistence farmers in their hundreds of thousands into entry-level commercial scale agriculture, and where they don't no longer just break even, but they begin to put cash in their pocket. And we encourage entrepreneurship, where people are actually making money and not just getting by. That is how we build an economy. And so medium Earth orbiting satellite, that MEO over there, the further away from the Earth the satellite network is, the more the part of the Earth it sees. As you can see, a schematic there of orbital altitudes and coverage areas. Low Earth orbiting satellites cover very small part of the Earth. The one that covered South Africa for 16 consecutive years, it had a swath of 150 kilometers. And so those narrow swaths, because of the Earth's rotation around its axis, and largely this satellite's inclination orbiting around the polar regions, crossing the poles, North Pole and South Pole, in a descending order and ascending order. Then over a period of time, every 16 days, you get total coverage of the entire planet. And remote sensing scientists get excited because now they have the data they need to even see slow changing phenomena as well as fast changing phenomena. Our defense need that data to plan for these peacekeeping missions that they do in other parts of South Africa, of the continent, to silence the guns. So we are intricately involved in these missions. And of course, the popular orbit is the orbit that brings direct-to-home television, which is geostationary Earth orbit. That orbit is designed such that the satellite in that orbit takes exactly 24 hours to complete one orbit around the Earth, which means to an observer on Earth, that satellite looks like it's not moving because it's synchronized to the rotation of the Earth around its axis. That's why your DSTV dish at home is not moving. So that is the scientific reason behind why the DSTV dishes are not moving. But if you are wondering why different dishes are looking at different parts, different directions in space, it's because of the different service providers in outer space. And when South Africa's telecommunication satellite is in orbit, it will be among those service providers that are giving services to entire areas. And of course, in Africa, the most highly desired area is West Africa, because that's where Nigeria is. That's the most populous nation. That means a big market, and economically, that means you're going to get your return on investment on your satellite system, because space is a business. It's not just public good services, but it's a business with return on investments. That's why you see people who are heavily invested in outer space exploration becoming billionaires, even becoming the world's richest people on Earth. I'm sure you know about the likes of Elon Musk, Jeff Bezos of Amazon, and this is why we want young people to begin to dream about how they will play in the space program of South Africa. Look, just introducing the agency that I work with, I believe this is the best space agency in the world. Not only because I work there, but because it gives us wings to fly and reimagine a South Africa not as an emerging spacefaring nation, and graduating to the intermediate spacefaring nations by 2030, which is what the current SANSA 2025 to 2030 ramp-up phase strategic planning horizon is targeting. We want to get out of emerging category and join countries like Brazil, countries like, India, and get into the advanced spacefaring nations where we have our own rockets, where we are building satellites that responds to uniquely African needs, and contributing to the African Space Agency that will be launched later this year in April in Egypt, and to achieve the aspirations of Agenda 2063. So you can see from the 4 existing SANSA technical programs that from the 1941 era, we've been monitoring the near-Earth space environment. We now form part of global networks, and we are operating a 24-hour operation space weather forecasting center in Hermanus in the Overberg district of the Western Cape province. And of course, when the moon landing missions were launched, the support was done from SANSA Space Operations when it was still within the CSIR Satellite Application Center. And of course, the space engineering facilitates the development of advanced satellite space missions that respond to South African needs from the user communities, government, as well as academia and private sector. The South African Incorporated. And of course, I'm at this Earth Observation Division, where we collect information about the land, oceans, and the atmosphere of planet Earth to study these phenomena that manifest in this environment, and so that we are better prepared to deal with climate change and adapt, so that we don't just become victims of climate change phenomenon. So SANSA Space Science, the 150 million kilometer laboratory, that's what we do at SANSA Space Science. Rockets going into space, we support them from SANSA Space Operations. This division generates 95% of its revenues in euros and in dollars from overseas companies and space agencies that are involved in launching spacecraft into space, including the Indian mission that explored the far side of the moon. We are working closely with India, with China, with other nations to actually excite our young people, Africa being the youngest continent on earth, to get excited about opportunities in space, including space tourism, them imagining themselves as future astronauts, because astronauts are the Americans, cosmonauts are the Russians, and taikonauts are Chinese. And of course, if they are from Africa, they will be called Afronauts. So I'm wrapping up. There are exercises we do in the classrooms. As you know, Polani, we reach out to young people through our science engagement, space education, space awareness program, and we show them how different time zones on planet Earth. Why is daylight here, but other parts of the planet are in darkness? And America, according to this map, even now in real terms, they are still in night time. It's early hours of the morning. I work a lot with them. In fact, this afternoon, I'm chairing a working group meeting of the Committee on Earth Observation Satellites. I'll be working with NASA, I'll be working with the Canadian Space Agency, European Space Agency, the Indians, Israel, and others from different parts of the world to build the capacity of organizations in developing countries to effectively use Earth observation for sustainable development. When we talk of Earth observation, we are talking about satellites observing the Earth. That is called remote sensing. It's one of the 4 application areas of space science and technology. The other 3 being global navigation satellite systems, telecommunications, as well as space science and exploration. So remote sensing is the 4th one, where we use passive sensors as well as active sensors. Passive sensors just means satellite sensors like Sumbandila Sat, which collects reflected radiation, doesn't have independent mechanism of actually illuminating a surface of the Earth and measuring the reflected radiation. That would have been an active sensor. So if it's only dependent on the sun, it means that one of its disadvantages is that when weather is not permitting, and at night as well, when the sun is not giving us that active illumination on our part of the world, these satellites then are rendered ineffective. So for many people, I know they say we drove past a place in Hartbeespoort there in the western district of Gauteng. We saw a lot of satellites. I want to correct many people who say that. What they saw, it's over 70 satellite dishes. These are antennas. They enable communication with satellites. They can transmit and receive, unlike your DSTV dish that only receives. So there is a difference between satellite and satellite dish. One is orbiting in outer space if it's man-made, but there are natural satellites as well. So the word satellite means helper, it means servant, it means attendant. And so satellites help us. They serve our needs. They are our eyes in space. They extend our visibility beyond the visible spectrum, 400 nanometers to 700 nanometers, that we are limited to as humans through our human eyes. And so they extend that, they operate in other parts of the frequency spectrum, and they use, infrared radiation. And, so they are able to discern things that our natural eyes are not able to. So they are able to even penetrate sub-meter level. So mining industry is using satellite technology to actually serve their interests in exploration. So the largest satellite ever built, not by one nation, but by multiplicity of nations, at least 8 countries. I know Japan and Canada are involved, United States. This is the International Space Station. It's on its last legs and it will be decommissioned. I mean, we're talking about where astronauts go in outer space to perform experiments where they test different things, including growing food in outer space, doing research, and coming up with seeds that are able to survive desert environments and enhancing food production capability. Space technology spin-offs have, I mean, in our houses today, we have microwave ovens. We have a lot, powder milk. These are spin-offs of outer space, what we feed our babies after they are born. That is spin-offs of outer space exploration, because when we send humans, we think about what will they eat. A depiction of geostationary Earth orbit direct to your house. That's GSTV, digital satellite television. And now I will close with the work that my unit does. We stimulate multidisciplinary thinking through science engagement, space education. Research has showed us that in the whole world, global statistics, only 2% of the population think, 3% think that they think, 95% would rather die than think. That's Dr. Ken McFarland's statistics. We support STEM education, science, technology, engineering, mathematics education for the knowledge economy. Beyond academics, you know, academic education is one part. It's not the only type of education existing. There's professional education, there's financial literacy, and we need to have these three types of education to be well-rounded scientists who are able to exploit business opportunities and build businesses around the space solutions that we generate. We promote the innovative use of space science and technology by the youth. We get young people to play using their mobile phones, understand the blue dot that they get on Google Maps, overlay satellite imagery on that Google Maps platform, and see their school and the building in which they are, and be able to collect spatially referenced data and be able to map these on open source GIS platforms, so that they start understanding that they can become consultant while they are in grade 10, not having to wait for them to have degrees. That is the future. So when a chief of a local village needs assistance with understanding Inmulechi, for example, Limpopo province, or Hammalebo, Limpopo province, and I'm just picking Limpopo because that is home. Your young people should be able to even help the Department of Agriculture extension officers with the Fetsatala project to be able to map plowing fields that their grannies are working on, so that they are able to say they comply with the 5-hectare limitation that the Department of Agriculture will assist people to plow and send tractors and implements and seeds and fertilizer, so that food security is enhanced by utilizing land that would ordinarily sit unutilized. And in Limpopo, for example, Agriculture Department wants to put online 1 million hectares. And now, as the space industry, we go beyond that. We say, let us evaluate the 5 districts of Limpopo: Sikukuni, Mupani, Waterberg, Capricorn, and Wembe district. Where do we find these hectares that we can bring online to produce food, to enhance food security? And we begin to see, because you can't plow on mountains, you can't plow inside big rivers and dams, so you begin to eliminate those through mapping exercises. Young people in schools can help with such activities, including students at universities. And of course, career opportunities. At SANSA, I'm a science communicator. It pays fantastic to communicate science. I mean, you have a gift, I have a gift. My tongue is my gift. I speak English like it's my first language. I rarely make grammatical errors. So to become an effective science communicator, You need to love English language, the Queen's language. But you need to understand the science, because you can't communicate the science you do not understand. So I've spent time studying satellite engineering, spending 7 years in a satellite ground station tracking satellites for government. And I have studied GIS and remote sensing, so that I am a well-rounded value chain traveler. I travel the entire space value chain, from the upstream, where we build satellites, launch them into outer space. I understand those processes. I understand the downstream, which is the Earth observation and global navigation satellite system. That's where you unlock value. That's where trucks are tracked from the coast to deliver fish inland. That's where, and the midstream, the satellite ground station environment, I'm well versed with that. So the career opportunities are across the space value chain. So what are the benefits of studying and practicing space science and technology? Multidisciplinary thinking. And I've given you the global thinking statistics. 2% think on Earth. 3% think that they think. 95% would rather die than think. Space education helps with developing that multidisciplinary thinking skill, problem-solving skills. So it converts consumers into producers. So household, businesses, and government are users and beneficiaries of space science and technology. And of course, many people still think that the Earth is flat. In the scientific world, all scientists do three things. We observe and document, and we question everything, come up with theories, and then we experiment to test the validity of the theories we come up with before we accept them as valid. So systems thinking, a human being is a system of systems. It's about lunchtime now. The digestive system will be at active levels. So air quality will respiratory system. A human body is a multiplicity of systems. Systems thinking helps you develop holistic thinking. We don't want people who think only dimension. You're talking about satellite systems, space mission analysis and design, which can help you build family mission analysis and design. African assets orbiting the African household economy. The whole is greater than the sum of its parts, and space is a global business. So it creates global citizens. And design thinking, I talk about an education system that will create a product where a 10-year-old is a millionaire. Now, that currently does not exist, especially in academic institutions. But there are 10-year-olds in South Africa who are multimillionaires because their parents think beyond a job. So there's more to a career than a job. A job is not a career. A job is just a man-made platform for exchanging your gift of value with the world. So we give you the world in the palm of your hands. So design thinking begins with the end in mind. And I hope that you entertain the idea to change the world, because that is the philosophy that will get us to the promised land where our economy grows at 6% year on year to create the kind of jobs our young people need. Here is an interesting observation I've made over the last 20 years plus while I was in the space industry. Outer space has 4 application areas: telecommunications, global navigation, satellite systems, space science and exploration, remote sensing. That's Stellenbosch University, the year 2000. Life lived by triple faceted beings called humans, spiritual beings, gifted with a marvelous mind, living in a physical body. Has got 4 application areas as well. And I challenge the young people on this platform, Polani, to tell me who the 8 people are who came together for them to be born. I know the 2 are the parents, the 4 are the grandparents, the 8 are the great grandparents. Where did they come from? Are you able to develop a map of where the 8 people who came together for you to be born, what your heritage is geographically? DDM is District Development Model. That would be a fantastic grade 10 exercise. And I'm working with the UK Space Agency to introduce Earth observation gently to young people, 14-year-olds to 16-year-olds. But I'm also in primary schools. So we want to create this awareness so that you don't think of space science and technology only used by the largest investor, being the government of a nation, but it can be used by households to improve their economy and their environment. So with that, I invite you to visit us at SANSA Space Operations in Gauteng, but we also have a facility in Hermanas as well. We provide this as a public goods service, and we do not charge you for coming to see the mighty ground station, the most diverse satellite ground station on planet Earth in terms of commercial frequency bands. So we cast our net wide. We make money from different applications of space science and navigation of the electromagnetic spectrum. So with that, Polani, I thank you and will be taking questions if there are any. Thank you very much for the opportunity.
I must say, marvelous, Mr. Vatsapola. I'm so enthralled. That was great for such a profound insight to certain things I didn't know. Yeah, there are questions in the chat, and one question that I would like to present to you that made me a bit concerned was that how do you maintain these satellites? Because they are forever orbiting, you know. So is there time to maintain the satellites? That is the question.
SANSA Space Operations, it's involved in the maintenance of satellite orbits. They even provide emergency support. You see, there's an imaginary box when you launch your satellite, where your satellite must live within that imaginary box. And there are monitoring stations across the world. NASA has them, Europe has them, Russia has them, China has them. We also participating in that space situational awareness. It's a capability we are busy developing. So that's how you maintain them. And you, when it gets out of its orbit, you use thrusters to actually push it back to its correct orbit, firing them carefully to make sure that you don't overfire and get it out into the graveyard orbit where it is destined after its mission lifetime.
Yeah. And then the next question, I think, is from somebody from a school in Soweto. How do you then name these satellites? Because there's one name that says Sumbandila. You know, where do these names get derived from? That's the question that yeah. How do you name this?
Each time we develop a satellite mission, we work with NRF SASTA, and that's the national coordinator of all science engagement in South Africa, to come up with a competition where we send it to all the schools and we say, here is a satellite we are building, this is what it's going to do. Give us an innovative name, uniquely South African name, that when it is registered at United Nations Office for Outer Space Affairs, they will see this is a uniquely African name. Sumbandila was named by a kid from Venda. It actually means, Sumba means point, Ndela is road, Kitsela in Spade is Tswana. So Supatsela, Sumbandela. And then Tshepiso Sat was named by a kid in Matatiele, that's Eastern Cape Province. That's why it's Tshepiso Sat. It mission of hope.
Right. Thanks you. I think this one question, it comes from an external visitor who also joined, saying, probably it's a student, we are encouraged to open our small businesses in advancing entrepreneurship. Can one run his or her own business when it comes to space?
If there's one thing I am famous for as the space education manager, is I constantly lament the fact that the majority of participants in the space value chain, particularly who look like me, they only see the jobs and not the entrepreneurial opportunities.
Yeah.
At SANSA, we advocate for entrepreneurship as well as intrapreneurship. If you read my profile, you would have seen that I grew my unit by 200% year on year.
Yes.
That's me doing intrapreneurship, but I am a trained entrepreneur. So I encourage South African young people not to entertain this idea of going to school, get good grades, graduate, get a good job with benefits, stay loyal until you retire, rely on your pension until you die. That is an outdated script of the industrial age. I'm saying to them, go to school, get good grades, graduate, and then build businesses and investment portfolios and become financially independent and then become financially free. If you go to school and get a job, you will be perpetually dependent all your life. What kind of value proposition is that? That's why we have such inequalities in our society. We need to build entrepreneurs and entrepreneurial mindset in our young people. I'm one who is an advocate for that.
I think one question before the last, it says, do you have a satellite that looks inside the sun? And what is it that you find inside the sun?
I stand corrected, but what I know are the satellites that are orbiting at very strategic distances from the sun's surface, 9 million kilometers away. Is one example. Yes, because if they get any closer, then you're going to face a serious existential threat from the sun. The sun, you cannot get to the surface of the sun. Those temperatures are just too high. So the best suited to answer this is Thandi Levuntu and any of the scientists at SANSA Space Science. But having done space weather forecasting in Australia myself, I can tell you there are satellites that are actually observing the sun. There are sunspots that are being monitored by these satellites. And these translate to different types of activity of the sun. And the sun goes through an 11-year solar cycle from solar minimum to solar maximum. During periods of solar highs, solar maximum, we have lost satellites like Sumbandila. We have lost satellites before. In fact, Elon Musk has launched satellites during period of peak solar maximum against advice that was given by such facilities as space weather forecasting centers, and lost those satellites. Needed emergency support from the likes of SANSA Space Operations to find them. Now, if you don't want that kind of close call, you simply adhere to advices that are given. That's why we provide advisory services to industry, even to pilots that are flying specific high-risk missions like South Africa, Australia. That's closer to the pole. And what do we know about the Earth's magnetic field? It diverts radiation towards the poles. Now, when you fly those routes, you accumulate higher levels of radiation. Pilots who fly those routes need to go for a regular checkup because there are thresholds they must not exceed. Otherwise, their health is in danger and they risk the lives of passengers that they are flying. So this is not disconnected from everyday life. As you can see, this space science and technology is very relevant to everyday living, and it helps businessmen extract maximum value, return on investment on their investments, and environmentalists to keep close tabs on the environment and how it is evolving, particularly in the era of climate change. So scientists, we are really necessary, especially as we migrate towards a knowledge economy from a resource-based economy.
Right. Here is a learner here who's cleverly naughty. Is asking, is a satellite now that you spoke about that, you can be able to even track trucks carrying fishes. Is satellite a camera or a spy? Can I connect by phone to it so that I can assist the police in catching criminals? Your own satellite. This learner is asking, can he or she connect your own satellites with his phone so that he can assist the police in tracking criminals?
Very interesting question, and I love that kind of a question. This is a practical entrepreneur in the making. I see a billionaire in the making there. Look, your phone can connect to a network of satellites. That's what we call global navigation satellite systems, and that allows you to navigate safely on Earth. But if there is an app developed to track elephants in the Kruger National Park, and that app allows tourism operators to be able to precisely locate where the elephants and the big five are, because of that tracking, that enhances tourism, and the tourists who come from different parts of the world will not feel like they've wasted money. So look, solutions are being developed, and they are accessed through digital platforms like cell phones. But then, of course, you need to have the right authorizations to know. A taxi owner in Mamelodi can actually track his taxis, and at any point in time can look at the app and see the geographic distribution where his taxis are, which ones are moving, which ones are exceeding the speed limit, and which ones are stationary, and make specific interventions such as is allowed by precision marketing that is done through programs of the 4IR, where we give the likes of Pick and Pay, the likes of many other stores, operators, through loyalty programs, our data, where we swipe a smart shopper points card and you tell them what you are buying. That helps them to know only to advertise to you the things that you buy and the things you are likely to buy. Oh, by the way, you even tell them the date on which you are paid. So that question is invoking so many applications, and there are so many. And at SANSA, we actually support young people who want to develop entrepreneurial ventures. We have programs like Neo Frontiers for small, medium, micro enterprises. So we encourage entrepreneurship. The only way we are going to fast track our migration towards becoming an intermediate spacefaring nation is when we leverage the intellectual capital of the majority of our population. Yes, in Western Cape, in Stellenbosch, in Somerset West, in Cape Town, we have companies that are exporting R1 billion worth of subsystems. These are engineering companies. And these companies have set themselves a target to, by 2030, 10 times that, 10x that, to 10 billion rand. What they say to me is they need human capital. And currently they are saying universities are not giving them what they want. They give them highly theoretical graduates. They want practical. So if you work with SANSA, we will expose you while you are studying to innovative, cutting edge stuff that will position you to be a different kind of graduate.
Yeah. So in short, if I were to relate this question of this learner, so it works both sides, a camera, and it can be, he can use it for espionage.
Well, people use tracking information in the US. Device. You can track your wife, man.
Okay.
Yeah, you can track somebody. In the US, there's a service where you can give a number plate and they tell you where the vehicle is. Tracker and this kind of service providers are doing such applications. But, a young person, I don't think, will be given authorization to deal with such sensitive information
Okay.
as relates to safety and security. That is law. That is law enforcement agencies that are authorized to deal with that. That's the intelligence of a nation. You will not be able to play with such sensitive data.
Okay.
But I like the thinking. I like the thinking of this young person.
It's very entrepreneurial. Thanks. This one is
Yes.
a plea. Can we get this type of education every 6 months each year? It's so thought-provoking. Or a newsletter of the advancement that SANSA is doing, or what is it that we are faced with when it comes to the latest on satellites. Even the astronauts that you spoke about. In our own stores, we can only see astronauts, not astronauts. Can you also, SANSA, sell clothes written astronauts?
Interesting.
That's a plea. That's a plea. Somebody's
Yes.
requesting.
I like that kind of thinking. Yes. You will be seeing a lot more of that happening. We are going big this time around in our 2025-2030 strategic plan.
All right, thank you very much, Mr. Den Matapula. That brings us, ladies and gentlemen, to the end of our Speak to a Scientist program event that we had for you. I'm here to invite even Mr. Den Matapula on the latest advancement that SANSA will be having for us. And trust me, if there are also those things, I'll definitely make sure that Sci-Bono keeps you up to date and connect you with SANSA as learners. Whatever programs that SANSA is having, they always communicate with us. I will also make sure that here in Johannesburg, because they are based in Pretoria, in Johannesburg, you are always hooked up to participate as well in their programs, competitions, whatever that they run, advancements, how satellites works, whatever that Mr. Matapula has shown us. Please, let's get involved and let's proceed beyond a job, as he said, that the job is not a career. Let's make sure that we go an extra mile. Thank you very much, Mr. Matapula. That brings us to the end of our Speak to a Scientist program event. Thank you, ladies and gentlemen. Thank you.
Thank you, Polani.
Thanks.